Hello, good afternoon. How are you all? How was your test? Yeah, good afternoon, Chichuni. Yes, how was the test? Everyone? It was easy, right? Yeah. So I will just wait for 1 minute. So my screen is visible and am I audible? My screen is visible and am I audible to you all? You can give me the response in the chat box also. Yeah, Chichuni, thank you. Yes. So the screen is visible to you and my voice is also audible to you. So today we are going to talk about the paper which was today, NEET paper. Okay. We are going to discuss about the test paper of chemistry. Okay, yeah. So Chichuni, how many questions you have solved today? Yes. How many questions you have solved today? There are any doubts? Okay. Okay. Let's see. Okay. So today we are going to solve the paper. Right now we are going to discuss about the paper. Okay. Yeah. So many people have joined right now. Hello everyone. Hi. Today we are going to talk about our paper discussion. Okay. NEET paper discussion. Okay. So let's start with our paper discussion. Okay. Okay. Very good. So first question, intensive property among the following is. So that this was very simple question. Intensive property among the following is ABCD: resistance, refractive index, mass, and volume. So what is the answer? Here, refractive index is the correct answer, right? Here answer is what? Refractive index. Right? Next question, oxidation state of cobalt in this given complex is. Any answers? 1, 2, 3, 4, ABCD. What is the oxidation state of cobalt in this complex? COAN2, ClBr, Cl. So here you can see these 1, 2, and 3. All three are negative ligand. But En, that is diamine, it is a neutral ligand, and that's why its oxidation state will be 0. Cl will be -1, Br will be -1, chlorine will be -1. Okay, so X plus kar do sabko. Add everything. Okay, add everything. What you will get? You will get X plus X minus 3 equal to 0. So you will get X is equal to 3. So what will be the oxidation state of cobalt here in this complex? Answer will be what? Option B. That is oxidation state will be +3. Right? Any doubt? You know how to calculate the oxidation state? Yes? Okay. So now let's go to the further question. Hybridization. Yes, Chichuni, thank you for responding. So hybridization of C1 and C2 carbon in the following molecules are. So our molecule is this one, and 1 and 2 carbons are this one. Okay, 1 and 2. So you can see here this carbon is attached to carbon double bond. Here hydrogen is there, and this carbon is attached to this carbon. Okay, carbon, 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 and hydrogen. So you can see there is a 1 double bond and 2 are what? Single bond. And this double bond contains 1 sigma bond and 1 pi bond. Okay, so that's why this is which hybridization? sp2 hybridization. So C1 carbon is what? Our sp2 hybridized. Okay, C1 carbon is sp2 hybridized. This is not correct. This is sp2, this is sp2, and this is sp. This is not again correct. Let's find out for C2. So for C2 carbon, you can see here double bond is present, double bond is present. So that is is attached to carbon, this is attached to carbon. So here 1 sigma, 1 pi, and here 1 sigma and 1 pi is present. Okay, so total 2 sigma and 2 pi bonds are present. So when that is the case, this is what sp hybridized carbon. So consider this. Okay, what this is what sp hybridized carbon atom. Okay, it is what sp hybridized carbon atom. So what will be our answer? Our answer will be very easy. B answer, sp2 and sp. Any doubt? Okay, let's move on to the next question. Which of the following enzyme is used for the conversion of proteins into amino acid? So when proteins are converted to amino acid, there is one enzyme which is used, which is known as pepsin. Okay. Okay, next. Slope of plot of ln k versus 1 by t. So this graph is what? Ln k and 1 by t. Okay, you know the equation. Yes, k is equal to a e raised to minus ea by r, right? K a e raised to Arrhenius equation, right? You know this Arrhenius equation, k is equal to a e raised to minus e by r. So when you draw the graph for this equation, now what you will get? K is equal to a e raised to minus ea by r. This is our equation. Okay. So here just put ln k. What will happen? Ln a plus ea by r. So here what will happen is ln a plus, here ae will go and here it will be minus ea by r. Right? Yes? Any doubt? Hello? Yes? Any doubt with that? So what will be our graph? Yeah, what will be our graph? Yes. So our graph will be option number. Can you see my screen? Hello? Yeah, now you must be able to see my screen. Okay. Yeah, so here what will happen? Minus ea by r and 1 by t. Okay, so I will write ln k is equal to ln a minus ea by r and 1 by t. So we have to draw a graph of ln k versus 1 by t. What will be the slope? You know, y is equal to mx, and this is what? Plus c. Right? Mx plus c. So this graph will be negative graph. Okay, slope is what? Negative. So it will be decreasing graph with the slope ea by r. Right? Yes? Right? Okay. Okay. So minus ea by r, answer will be what? C. Maximum solubility of AgCl. Yeah, so can you see the screen now? Yeah, you can see the screen now, right? Share is on, I think. Yeah, you can see the screen. Very good. Next, maximum solubility of AgCl is. So here, AgCl solubility we need to calculate. Okay, we need to find out in which of the solution, NaCl, NaOH, sorry, NH4OH, AgNO3 and CaCl2, in which of the following solution the solubility of AgCl will be maximum. So we have to consider here common ion effect. What we have to consider here? Common ion effect. Why we need to consider a common ion effect? If when you are dissolving any substance in another substance, right? So we need to find out that there should not be any common ion with the soluble substance. If there is a common ion, then the PPT, what we can say that the precipitate of the soluble compound is decreases. Okay, so when a soluble compound with a common ion to the precipitate is added, the solubility of such a precipitate decreases. What happens? Solubility of the precipitate decreases. But what we want? We want maximum solubility. So in order to have a maximum solubility, we should just consider that AgCl should be soluble in such a compound or in such a solution in which Ag is not present as well as Cl is not present. So there will be no any common ion. So here NaCl, Cl is common. So this is not true. This is not good. AgNO3, Ag is present. It is also not good. CaCl2, Cl is present. This is also not good. We have to choose a solute or a solution in which Ag or Cl ion both are not present. Okay, so what is our correct answer? NH4OH. Sometimes instead of these, pure water is given. So our answer will be pure water. Okay, please remember this. Okay, the concentrations are not going to affect anything here. We just need to find out the ions. Okay, which ions are present in a given solution. If Ag plus and Cl minus are present, then there will be common ion effect, and due to this, solubility of precipitate decreases. Okay, and that's why here we want maximum solubility. So that will be our answer. Sometimes cross question can be asked. Instead of maximum solubility, minimum solubility can be asked. And that time we need to consider the common ion effect. Is that clear to everyone? So 2 questions we have talked here. Okay, discussed here. Next, minimum molar mass. So you know the formula for minimum molar mass, right? Minimum molar mass. Last exam में हमारा problem था is equal to atomic mass of that given element divided by percent of that given element into what? 100, because percent is given, right? So minimum molar mass of a protein that contains 0.7% by mass of nitrogen will be. So here we need to find out the molar mass for a given compound. So in order to find out that molar mass, we need to put the atomic mass of a given element. So what is the element? Nitrogen. Divided by its percent, 0.7%, multiply by 100. You just do this simple calculation, you will get the answer B. That is 2000 U. Any doubt? Yes, green is visible, right? Everyone? Yeah, next. Which colligative property is used for the determination of molecular mass of protein? Thank you for responding. Yes, thank you. Which colligative property is used for the determination of molecular mass of protein? So proteins are what? Macromolecules. Proteins are what? Macromolecules. So we need to find out the colligative property which is applicable for macromolecules. You know that other 3 colligative properties except osmotic pressure are applicable for microscopic, right? So since our colligative properties are proteins are very high molecular weight components, that's why osmotic pressure is the colligative property which is used for the determination of its molecular mass. Next question, IUPAC name of the given compound is. Anyone knows this answer? ABCD? ABCD, yeah. How we can discuss this? How we can solve this problem? So here we need to start. Yeah, okay, let's see, okay. So we need to start with the options, okay. IUPAC name of the compound given below is. So you know that we need to start from alphabetical order. Okay, alphabetically, how many substituents are present? 3 substituents. Here bromo, this is methyl, and this is chloro. Bromo, methyl, and chloro. Right? So we need to start writing the name of a given organic compound alphabetically. So first of all, we need to put the numbering, right? So 1, 2, 3, and 4. So the answer will be 4 bromo, 1 chloro, okay, 2 methyl cyclohexane, and that answer is option number 4. 4 bromo, 2 chloro, right? C answer will not be there because 4 bromo, 3 methyl means what? That is not correct, right? If you are giving 4 number here, then methyl group, how it will get 3 number, right? Chichuni, are you getting this? Yes, any doubt? It will be 4 bromo, 1 chloro. Yeah, okay, next. 61 problem. Here, we have asked what will be the major product for this given reaction. Okay, what will be the major product for this given reaction? So here you know that this reaction is SN2. Okay, this reaction follows SN2 mechanism. So in SN2, what is the product? Inversion product we get. Okay, inversion product we get, that is Walden inversion. And in that, Cl will get replaced or substituted by OH. right? So this will be not our answer. Racemic mixture will not be our answer. And this is also not, this is what? Elimination. This is not substitution. So that's why our answer will be option A. Okay. Any doubt? Yeah. Next question. Which of the following gases will give maximum deviation from ideal behavior? So whenever such question is asked, you need to find out a compound or a gas in which, or a solution, CO2, NH2, NH3 and CH4. Okay, so gases, we need to find out such a gas in which hydrogen bonding is not present. Okay, that will not give a maximum deviation. But here NH3 is containing hydrogen, and that's why it will have the hydrogen bonding. And since it is having hydrogen bonding, it will show the maximum deviation. It is going to show us the maximum deviation. So our answer is what? What is asked? Maximum deviation in which ideal behavior under similar condition, which gas will give. So NH3 is our answer. It is going to give us a maximum deviation. Right? Any doubt? Okay. Next question. Aqueous solution of which of the following ions will be colorless? So in order to be a solution, in order to have a solution to be colored, what is the requirement? It should have a DD transition in it. Means what? It should have D electrons. So here Cu2 plus, you know, it is D8, right? It is what? D8. Fe3 plus D6, 4s2, so D5. Chromium 3 plus 5, 1, 1, it is D3. Yeah, here it is D0. So since it is not having any oxygen, any electron, not oxygen, okay. Since it is not having any electron in the orbital, so there will not be any DD transition occur. And since there will not be any DD transition, this compound is what? Colorless. Okay, solution. Aqueous solution of Sc3 plus Candium 3 plus ion will be colorless. So our answer is option D. Yes, in doubt? Okay, next. So here D9 will be written there, okay? Copper is 29, right? D10, 4 is 1, yeah, D9. This is 6, 2, yeah. This is correct. Next, chlorine water and on standing loses its yellow color due to formation of. So here, chlorine water, chlorine when reacts with water, okay, when it is present in presence of water, there is a formation of HCl and HClO. Sorry, yeah. There is a HOCl. Okay, you can write it as a HOCl. Okay, HO, HCl and HOCl is going to be forming there due to what? Sunlight. Okay, this solution has yellow color, but due to the presence of sunlight, what happens is that HCl and HOCl gets formed, and these are colorless, and that's why the yellow color fades off on standing the chlorine water. Okay. Yes. Next, an oxide of nitrogen which is obtained by thermal decomposition of lead nitride. So lead nitrate's structure. What is the lead nitrate structure? Yes, it is what? PbNO3 twice. Okay, this is what? Lead nitrate. Okay, it's on heating. Okay, it's on heating gives us what? NO2. It gives us NO2, 4NO2. Okay, 4NO2 plus Pb oxide, and we get oxygen also. So here what is happening? An oxide of nitrogen which is obtained by thermal decomposition of lead nitrate will be what? NO2. That is our option is answer A. Okay. Yes. Next problem. Very easy. Yeah. Tell me the answer. Consider the following reaction. NaBH4 will give a major product. What will be the major product here? ABCD. NaBH4 is what? Reducing agent. It is going to reduce the carbonyl groups. Okay, there are two types of carbonyl groups present here. One is a ester and another one is a keto group and ester group. So which will get reduced by NaBH4? You know that? Do you know this? Any answers? ABCD, any options? You're going to tell me what you have marked in the exam. ABCD, wrong भी चलेगा, कुछ नहीं प्रॉब्लम, हम डिस्कस कर रहे हैं ना अभी पेपर, गलत भी हो गया तो भी चलेगा, ठीक है. ABCD, any responses? C. Okay. So now NaBH4 is a reducing agent, okay, which is a mild reducing agent. It reduces aldehyde and keto group, as well as it reduces acid chloride, right? Last paper we have seen, okay, CO group of these it reduces, but it doesn't reduces the ester. It doesn't reduces the ester. So what will happen in this reaction? Ester COO, okay, ester carbonyl group will be intact in the product, and only keto CO is going to reduced. So what is that answer? ABCD. What is that option? Yeah, just observe the options and tell me the answer. Yes. A answer. Okay, Mohini. Very good. A answer is correct answer, because keto will get reduced to alcohol and ester will be as it is. Next problem, C, orthonitrophenol and paranitrophenol. Right? Orthonitrophenol and paranitrophenol. There are two statements given to us about them. First statement is orthonitrophenol and paranitrophenol can be separated using steam distillation. So when we talk about steam distillation, there we can separate the two compounds if there is a big difference between their boiling points. If there is a difference between their boiling points. Statement 2, intramolecular hydrogen bonding exists in orthonitrophenol. So this statement suggests that there is a hydrogen bonding between orthonitrophenol. This is an intramolecular hydrogen bonding. Again, in the second component, that is paranitrophenol, there is also hydrogen bonding, but this hydrogen bonding is what? Intermolecular hydrogen bonding. In the light of the above statement, choose the correct answer. We need to find out the correct answer. So statement 1 is incorrect, 2 is true, 1 and 2 both are true, both are false, 1 correct, 2 false. So your answer is what correct? So let's talk about that. So in orthonitrophenol, there is an intramolecular hydrogen bonding, but in the paranitrophenol, there is an intermolecular hydrogen bonding. Okay, so since due to the intramolecular hydrogen bonding, this have low boiling point, and due to the intermolecular hydrogen bonding, this is having high boiling point. Okay, one molecule combined with the another molecule, their hydrogen bonding is strong, and due to this strong hydrogen bonding, it is very difficult to break that molecules. Okay, it is difficult to boil the given paranitrophenol, and that's why its boiling point is high. On the other hand, intramolecular hydrogen bonding is present in ortho, and that's why it is having low boiling point. So since you can see here, they are having vast difference in their boiling point, low and high, and so that they can be separated by using steam distillation. So both the statements are true. Okay, any doubt? Next, consider the following reaction sequence. So here we have given one reactant molecule, okay, and 3 arrows are given, and we need to find out C. What is the C answer? Yeah, so can you tell me what is the C answer you have marked in the exam? C, A, B, C, D. Okay. So the reactant molecule is what? Aniline, right? So aniline, what happens when aniline is there? So aniline, when it reacts with, okay, acetic anhydride, when it reacts with acetic anhydride and in presence of pyridine, there is a formation of A molecule. Okay, there is a formation of this amide. Okay, there is a formation of aromatic amide. When Br2 reacts with it, there is a electrophilic aromatic substitution. Okay, and bromine group goes to the para of this amide. And next, when hydrolysis takes place, Okay. There is a breaking of this amide group and hydrogen is taken by this amine and there is a formation of this type of compound. Okay. And which is that A, B, C, D. It is what? Option C. Any doubt here? What has happened? NH2 reacts with the acetic anhydride. Okay. Do you know the structure of this? CH3, CO, O, right? CO, CH3. This is the structure. Okay. Next, any doubt? You get the reaction, right? Yeah. Okay. Next. Next reaction, the artificial sweetener which has the maximum sweetness value in comparison to cane sugar is. So there are 4 options given and we need to find out the artificial sweetener which is having maximum sweetness value in comparison to cane sugar is. So your answer is D, that is allicin. Okay, which is having 2000 times more sweetness as compared to the sucrose. Okay, in comparison to the sucrose, this is very, very sweet. Next, the correct order of decreasing energy of orbitals for beryllium atom is. So, you know that in order to solve this question, we need to consider N plus L. N is what? Principal quantum number. L is what? Azimuthal quantum number. So energy of any orbital increases with increasing N plus L value. Okay. Energy of any orbital increases with increasing N plus L value. So for the same N plus L, the orbital with higher N will have higher energy. Okay. Orbital with higher N will have higher energy. So here you can see that there are 3 orbitals, 5p, 3d and 4s. So here L value is what? For p, you can, L is equal to 0, L equal to 1 and L is equal to 2. 0, S, this is p, this is d, right? So here I have written 5p. So p means L is equal to 1, d means L is equal to 2, S means L is equal to 0. And here N value, what are there? 5, right? Principal quantum number, here N value is 3, here N value is 4. Sum these. You will get 6, you will get 5, you will get 4. So which is having N plus N value more? Here, which is having N plus N value more, that will have the higher energy. So here you can see 6 over 5 over 4. So what will be the correct answer? A, B, C, D option. 5p will have more than 3D than 4s. Right, very good. So option C will be correct. Next, Eka silicon and Eka aluminum respectively are also known as, this is very simple problem. Okay, it is given in NCERT, right? So answer is what? Germanium and gallium are the Eka silicon and Eka aluminum. Okay, any doubt? Okay, now next go to the next problem. That is what? Most stable peroxide among the following is. So Li2O2, Na2O2, K2O2, Rb2O2. So here stability of peroxide increases. Stability of a given peroxide increases with increase in the size of cation. With increase in the size of cation. So here cation is what? Li. Lithium का cation, sodium का cation, potassium का cation और rubidium का cation. Okay, so whose size of the cation is bigger? Rubidium is the biggest cation present here. Okay, because why we need here big size of cation? Because by stabilizing the large anion, because large size of cation will easily stabilize the large size of anion, and that's why we need to find out here large size of cation in order to consider the stability of peroxide ion. Okay, when large size of cation combines with the large size of anion, there will be lattice energy. Okay, there will be certain lattice energy which is going to affect stability of a given peroxide. So in order to consider the stability of peroxide, it increases as there is a bigger size of cation present. Okay, please remember this. So our answer will be option D. Size increases from A to D. Okay, Next problem. When anhydrous borax is heated with platinum wire coated with COO, cobalt oxide, in a Bunsen burner flame, the blue colored bead formed is, okay, the blue colored bead formed is. So here, borax, you know the structure of borax, right? Yeah, the structure of borax. What is the structure of borax? It is Na2B4O7. Na2B4O7. Okay, into 10H2. This is our borax. You know the borax bed test, right? Borax bed test. So when this component is heated in presence of platinum, okay, so here there is a production of anhydrous borax, which is given. There is a production of anhydrous borax. Anhydrous borax means what? Yes, anhydrous borax means what? This H2O will be not present. So we will get Na2B4O7 plus NH2O. Okay, this will be our product. When this is coated with COO, cobalt oxide. Okay, so what we are going to get about the blue colored bed? So we are going to get here COBO2 twice. Okay, then NaBO2 and then B2O3. So these are our three products. And the blue colored bed is due to this COBO2 twice. So here what we are going to get? We are going to get here, I will just write it fast, okay? BO2 twice plus B2O3 plus NaBO2. So these are our product and this will give us the blue color. This is going to give us the blue bed. Okay, so that is our correct answer, option A. Next, pH of acid rain is, हम लोगों ने अभी परसों ही बात की थी एसिड रेन के बारे में. Okay, when water is having less than 5.6, it is what? Acid rain. Right? pH 5 less than 5.6, it is what? Acid rain. So answer will be C. Next, we have given the hydride list and we have categorized. There are categories of those hydrides: NaH, CrH, HF, and CH4. Which are those hydrides? Metallic hydride, electron precise hydride, electron rich hydride, and saline hydride. So your answer is what? Our NaH. Do you know NaH is what? You know, na? Saline is given. So this is what? Saline hydride. NaH is what? Saline hydride. And chromium hydride. Chromium is metal. Okay. Sodium is also metal, but it is a saline hydride. And chromium hydride is what? Metallic hydride. Okay. HF is what? Electron rich hydride. Okay. HF is what? Electron rich hydride. And CH4 is what? Electron precise hydride. So please remember these, and our correct option is what? A. Here our correct option is what? A. Okay. So NaH is saline hydride, or you can call it as a ionic hydride. Saline or ionic. But chromium is what? Metallic. HF is electron rich and CH4 is electron precise hydride. Okay. Any doubt? Okay, we will move on to the next question. Composition of German silver. So German silver contains copper, okay, copper, nickel, and zinc. It contains copper, nickel, and zinc. So copper is present around 25 to 30%. 25 to 30%. Zinc is again same 25 to 30%, but nickel is around 40 to 50%. Copper, zinc, and nickel. So copper, zinc, and nickel is present. This is tin. This is not correct. This is Ag. This is not correct. This is again Ag. This is not correct. So copper, zinc, and nickel. That is our German silver. Okay, copper, zinc, and nickel. Next, in acidic medium, MnO4 minus as an oxidizing agent changes to. So we have seen many redox reactions, right? MnO4 minus, when it is present with the acid, okay, in acidic condition, you know the Hello? Hello? Am I audible and my screen is visible? Yeah, thank you. Okay, there was some problem, I guess. Okay, next problem. Let's talk about sodium oxide. Okay, sodium oxide having anti-fluoride structure. Coordination number of sodium and oxide ion respectively are. So you know that in anti-fluoride structure, sodium ions, you know that in anti-fluoride structure, sodium ions are present at the tetrahedral sites. That's why the coordination number of sodium is 4. And for O2 minus, it is what? 8. It is what? 8. So sodium ion is present at the tetrahedral position. Sodium is present at the tetrahedral sites. Okay, sodium is present at tetrahedral site. That's why its coordination number is 4 in anti-fluoride structure. And for oxide ion, it is what? Its coordination number is 8. So 4 and 8 will be our answer. And that's why our answer will be option B. Okay? Okay? Okay. So next question. What will be the answer? Reduction potential of hydrogen electrode in contact with the solution having pH. We have given the pH and we need to find out the reduction potential for this. So you know the Nernst equation, right? E cell is equal to E naught of cell minus 2.303 RT. Yeah, you know, product divided by reactant concentration, right? So I'm going to use the Nernst equation here and I'm going to solve and calculate the reduction potential for hydrogen electrode. So here you can see here in hydrogen electrode, what is going to happen? H2 is going to convert into what? H plus, right? So H plus acquires those electron and gets converted into H2. Okay, so this is our reaction. So our Nernst equation will be E cell for this electrode, hydrogen electrode, is equal to standard reduction potential of hydrogen electrode minus 0.0591 upon N, okay, 2.303 RT upon NF. Okay, RT upon NF I have written here. So 0.0591 upon N log to the base 10 of product divided by reactant. So in product, what is there? This is product and this is reactant. So pressure of hydrogen gas. Okay, it is a gas. That's why we need to consider its pressure. So it is given that pressure of hydrogen gas is what? 1 atm. In problem, it is directly given. So here it will be 1. So our equation will rearrange in this way. And you know that log of 1 upon H plus is what? pH, right? So whatever will be the pH here, we will directly put and we will get this answer. Okay, and we are going to get this answer, right? Very simple problem for hydrogen electrode. This question can be reframed in different ways in order to do the question. Okay, आपको कौन सा भी पूछ सकते हैं. यहाँ पे आप लोगों को रिडक्शन पोटेंशियल पूछा था, आपको यहाँ पे pH निकालने के लिए भी कह सकते. ठीक है, so that can be the reframing of a given question. So this is good question actually, very good question. Okay, and in this way you have to use the Nernst equation and we have to solve this. Okay, pressure of hydrogen gas. Okay, it is a gas. That's why we are considering the pressure. Any doubt? Okay, very good. Next question. A metal crystallizes with face-centered cubic lattice. The age of the unit cell is 440 picometer. The radius of metal atom is nearly. So here we have to find out the radius of metal ion for face-centered cubic lattice. So do you know what is radius for FCC? What is the radius equation for FCC? FCC, it is what? 4R. For FCC, 4R is equal to under root 2A. So we need to find out the R. So R is equal to under root 2 by 4 into A. What is A value? A unit cell value we have given 440 picometer. Just do the simple maths and you will get the answer, right? So this is your formula. 4R is equal to root 2A. R is equal to root 2 by 4A. Okay. Our answer will be C answer. Option C, 155.5 picometer. Next question. Most stable carbanion among the following is. So, in option A, what is there? The negative ion is present here in this CH2 group. Okay. There is no stabilization given to that. No donating, no withdrawing group is present. Okay. Here, withdrawing group is present, but that is present at meta position. So, it is not a good position. Okay. For the withdrawing group. You know that this is what para position. So at the para position, withdrawing group is present, and this is a correct position because it is going to stabilize the given carbanion. Okay, it is going to stabilize a given carbanion. Here, this is what donating group. This is also not good option in order to stabilize the carbanion. So our correct answer will be what? C. So NO2 at para position stabilizes this carbanion present on CH2 group. Okay, option C will be our correct answer. Next, any doubt? Okay, next problem. See, which hydrocarbon cannot be prepared by using cold electric method? So this is very basic question. So by using cold electric method, methane cannot be prepared. So why it cannot be prepared? See here, I have given the reaction of cold electrolytic method. Here I have taken a given carboxylic acid salt. Its electrolysis, when done, there is a formation of N-butane. Okay. When there is a ethyl salt, there is a ethane. When there is a like this compound, there is a ethene. But methane cannot be prepared by using such a method. Okay. Please remember, cold electrolytic method, very, very important method. Okay. Sometimes question is asked about the product, which product is going to form. And right now, which will not form is asked. So methane is the product which is not going to form. Next question, 84. Major product of the given reaction is PH, CH2CN, CH3MgBr, and CH3O plus. So here, what will be our correct answer? A, B, C, D. So here, what will happen? See, I have written the cyanide and I have written the Grignard reagent here. So what will happen? This negative part of the Grignard reagent is going to attack on the carbon atom of cyanide. And in this way, the electron is going to shift. And we are going to get this intermediate state. Hydrolysis will take place. And during this hydrolysis, what will happen is oxygen will go to this and H2 will go to this. And we will get the keto group, COCH3. So where is the COCH3, ABCD? So our answer here is what? For 84, answer is what? B. Yeah, next question. Lactose is composed of. So lactose, it is a very basic compound. Okay, it is composed of glucose galactose, and glucose fructose. But alpha D hai ya beta D hai, that is the major question. So here, see the structure. Here, beta D galactose and beta D glucose. When they combine together, there is a formation of lactose. So our correct answer will be for 85, beta D galactose and beta D glucose. So answer is option A. Among the following complexes, which is optically active. So in order to a given compound to be optically active, we should have a compound metal. Okay, A, B, C, D. How many here? 3 means it is what? It is octahedral complex. So A, B, C, D, E, F. This is A, B, C, D, E, F. Okay, A, B, En is what? Dimethyl, na? Ethylene diamine. So it is bidentate ligand. Okay, A, B, C, C, E, E. Yeah. So here option D is the correct answer. See, I have drawn the molecule. There is no plane of symmetry in the given compound. But when you draw all the 3 compounds, na, A, B, C, there are three, they are same. 6 here. Okay, primary valencies are 6. Here 4 NH3 and 2 Cl2s are there. So they are going to have the plane of symmetry in the compound. And our basic assumption, basic requirement in order to have a compound to be optically active is that there should not be any plane of symmetry, and our option will be option D. That is our correct answer. Next, 1 mole of monoatomic gas expanded against 2 atm pressure for 10 liter to 60 liter at 27. What is the work done? So here we need to find out the work. ओके, मोनोएटॉमिक गैस दिया हुआ है, प्रेशर दिया हुआ है, वॉल्यूम दिया हुआ है, टेम्परेचर दिया हुआ है, नंबर ऑफ मोल्स दिए, वर्क निकालना है. व्हाट इज आवर फॉर्मूला? W इज इक्वल टू P एक्सटर्नल VF माइनस V हाई. प्रेशर पुट करो, वॉल्यूम पुट करो, यू विल गेट द आंसर. वेरी सिंपल प्रॉब्लम, वेरी 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 सिंपल. माइनस 100 लीटर पर लीटर ATM, सॉरी नॉट लीटर पर ATM, बिकॉज वर्क डन इज इक्वल टू PV. यस, 87 का आंसर है हमारा B. Next, assuming x-axis as a internuclear axis, which of the following will show zero overlap? 2s, 2px, 2s, 2s, 2py, 2py, 2px, 2py. Yes, so answer will be what? 2px and 2py will show zero overlap due to different orientations. Okay, these are what our orbitals, right? So 2px and 2py will show zero overlap due to different orientation. That will be our correct answer. Next, Kp is equal to Kc for which of the following equilibrium? So here we need to find out for which reaction Kp is equal to Kc. So you know this relation, Kp is equal to Kc into RT raised to delta Mg. So for the reaction H2 plus Cl2 gives 2HCl, delta Mg change in the number of moles is 0. That's why it will have Kp equal to Kc. Okay, since it is 0, ये क्या हो जाएगा? 1 हो जाएगा. फिर Kp is equal to Kc we will get. So our answer will be option C. Any doubt? Yeah. Next question. Which of the following is correct for first order? Hello, you can hear me, right? Which of the following option is correct? So A, B, C, D. Yeah, can you give me the answer? A, B, C, D, which is the correct? A correct. Okay. Okay. So half-life for first order reaction is what? 0.693 divided by K. Therefore, it does not change with time. Therefore, it does not change with time. So the answer for question 90 is what? C. It is what? C. Because half-life period does not change with time, it remains constant. It remains constant. So our answer will be what? C. Next, 91 principal emulsifying agent of oil with water emulsion is synthetic soaps, lamp black, long chain alcohols, heavy salt of fatty acids. Heavy salts of fatty acids. So our answer here is what? Synthetic soap is the principal emulsifying agent. Principal emulsifying agent like oil in water emulsion. Like oil in water emulsion. For oil in water, synthetic soaps are very good. Okay, please remember this. Oil in water, water in oil emulsion. Okay, emulsions are very, very important. Okay, one question is asked. Next, expression of compressibility factor for real gas at high pressure will be. So here for high pressure, we need to find out. Okay, so you know the equation, van der Waals equation, P plus van der Waals equation. What is that van der Waals equation? There are two equations for ideal gas equation and the gases which do not follow the ideal gas equation, they follow the van der Waals equation. So we need to put very high pressure, consider very high pressure for van der Waals equation. Okay, so what is the van der Waals gas equation? It is what? P plus A N V square V minus N V RT. This is our van der Waals equation. Here we are considering for 1 mole. So that's why N is equal to 1 I have put. And now this is our van der Waals equation. Here we have to consider very high pressure. So pressure is very, very greater than this term. So this term will go. And what will happen? Here P V minus B equal to RT. So rearrange this equation. P V minus B equal to RT. Just rearrange this equation. You can see here PV upon RT minus PV upon RT is equal to what? 1. So what I have done, I have transferred this minus term to this side and you will get this answer. That is PV by RT is equal to 1 plus PV by RT. Okay. And what is Z? PV by RT is what we are Z. So what is correct answer here? A, B, C, D. ऑप्शन आपके सामने है. यहाँ पे आंसर हो जाएगा हमारा ए. सो Z इज इक्वल टू 1 प्लस PB अपॉन RT. राइट. ओके, नेक्स्ट प्रॉब्लम. नाइट्रोबेंजीन ऑन रिडक्शन विथ लिथियम एल्यूमिनियम हाइड्रेट इज. सो यहाँ पे हमारा रिडक्शन हो रहा है नाइट्रोबेंजीन का, तो हमको क्या मिलेगा? So see the reaction here. I have written the reaction. Nitrobenzene on reduction with lithium aluminum hydrate gives azobenzene. Gives azobenzene. That is option C is correct answer. Okay. Next problem. Which of the following pair of d orbitals has zero electron density along the axis? Zero electron density along the axis we want. Okay. So we need to consider here orbitals which are in between the axis. So you know dxy, dyz and dxz, these three orbitals are in between the axis, and that's why they will have zero electron density along the axis. So our option will be ABCD में से कौन सा आएगा अभी आंसर? जो दूसरे बचे ये जो है dxy स्क्वायर और dz स्क्वायर, ये क्या है? along the axis है. ठीक है, तो इनका जीरो इलेक्ट्रॉन डेंसिटी नहीं होगा. So dxy, dxz, dyz will have the electron density 0. ओके, सो 94 का आंसर आ जाएगा हमारा डी. ओके, नेक्स्ट क्वेश्चन. द करेक्ट ऑर्डर ऑफ इंक्रीजिंग नेगेटिव इलेक्ट्रॉन गेन एंथैल्पी फॉर द फॉलोइंग एलिमेंट इज. वी नीड टू फाइंड आउट द इलेक्ट्रॉन गेन एंथैल्पी. Increasing negative electron gain enthalpy. So electron gain enthalpy becomes less negative on going down the group. Okay, because size of, why this is happening? Because the size of atom increases and the added electron experiences less nuclear charge, and that's why it is decreases. It is decreasing as we go from top to bottom. Okay, so electron gain enthalpy becomes less and less negative as we go down the group because of the size of the atom increases. Okay, extra shell add hota hai, isliye size of the atom increases, and this added electron experiences less nuclear charge. That's why it is having less negative electron gain enthalpy. So what will be your correct answer? ABCD. Yeah, ABCD. Yes, we need to find. So this is for alkali metals, lithium, sodium, potassium, rubidium. As we go down, it will have less electron gain enthalpy. So we need to find out option in which lithium is first one. Okay, so C is our correct answer. Rubidium, then potassium over sodium over lithium. Next, oxidation number of oxygen is minimum in oxides, peroxides, superoxides, dioxygen. So किसमें कम है? देखो, ऑक्साइड्स दिया हुआ है, peroxide दिया है, superoxide दिया है, dioxygen है. This is oxides, this is peroxides, this is superoxide, and this is dioxygen. You can see here, this is -2, -1, -half and 0. Yeah, which is less. कौन सा लेस होगा? -2, -1, -half या 0. What is lesser? Least. -2, -1, -half and 0. Which is least? Which is minimum? Less. So oxides are having less oxidation number. ठीक है? Yeah, very good. A answer. Next, the value of log Kc for the equation is, for the reaction is, Kc के लिए हमको E नॉट दिया हुआ है, ये भी नॉट दिया हुआ है, हमको Kc की वैल्यू पूछिए, log Kc की वैल्यू. ठीक है? We have asked to find out log Kc. Yeah, so what will be the answer? Let's solve this problem. You can solve first of all E naught. E naught will be what? E naught of Ag minus E naught of iron, and you will get E naught cell like this way, 0.03 volt. Next, use this equation. E naught cell is equal to 0.591 upon n log K. Put the E naught cell value. Log Kc will be like this way. Just transfer the terms and इक्वल टू के लिए log Kc लिख लो, आपको आंसर मिल जाएगा. वेरी इजी प्रॉब्लम, 0.5. सो आवर करेक्ट आंसर इज व्हाट? डी. ओके, नेक्स्ट, जलदाल टेस्ट करना है हमको. जलदाल मेथड में क्या होता है? व्हाट इज द परसेंटेज ऑफ नाइट्रोजन प्रेजेंट इन द कंपाउंड? सो मिली इक्विवेलेंट ऑफ H2SO4 इज इक्वल टू मिली इक्विवेलेंट ऑफ अमोनिया. ओके, यहाँ पे हम लोगों को नाइट्रोजन कितना प्रेजेंट है? अमोनिया इवॉल्व हो रहा है, न्यूट्रलाइजेशन हो रहा है H2SO4 के साथ. ठीक है, H2SO4 का न्यूट्रलाइजेशन हो रहा है अमोनिया के साथ. सो मिली इक्विवेलेंट ऑफ अमोनिया हम लोगों को मिल रहे हैं यहाँ पे 15 into 2 is equal to 30. So mass of nitrogen will be what? 30 into 14 into 10 raised to -3. So you will get percentage in terms of 42%. उसको परसेंट से मल्टीप्लाई कर दिया, हमको आ जाएगा आंसर 42% मिली इक्विवेलेंस. ठीक है, पे लॉ ऑफ इक्विवेलेंस यूज करना था. Yeah, any doubt? Next problem, very simple. The compound which liberates hydrogen gas on reaction with sodium metal is. So this reaction is very easy reaction. Okay. So terminal alkynes contain acidic hydrogen. These compounds liberate H2 gas on reaction with sodium. So when we have the terminal alkynes, then and then only they are going to liberate the H2. So यहाँ पे terminal alkynes है क्या? नहीं है. ये तो alkene है, ये भी नहीं है. यहाँ पे भी alkene है, ये भी नहीं. This is what terminal alkyne. So this is going to liberate the hydrogen gas when it reacts with sodium metal. So our correct answer will be option A. Next, the compound which does not show ketoenol tautomerism. So the key factor, the very important thing in order to occur a ketoenol form, in order to have the ketoenol form is what? It should have the alpha hydrogen atom. तो यहाँ पे देखो अल्फा हाइड्रोजन है क्या? 1 2 3 and 1 हाइड्रोजन इज प्रेजेंट. 1 2 3 यहाँ पे भी हाइड्रोजन प्रेजेंट है, बट यहाँ पे हमको क्या बोला? डज नॉट शो. सो यहाँ पे हाइड्रोजन है, यहाँ पे भी हाइड्रोजन है, सो इट इज गोइंग टू शो. यहाँ पे देखो हाइड्रोजन है क्या? ये मिथिल ग्रुप मिथिल ग्रुप मिथिल ग्रुप, ये मिथिल ग्रुप मिथिल ग्रुप मिथिल ग्रुप. यहाँ पे हाइड्रोजन नहीं है. यहाँ पे देखो ये दो मिथिल ग्रुप है, लेकिन यहाँ इस साइड में हाइड्रोजन है ना, राइट? एट दिस साइड देयर इज अ हाइड्रोजन प्रेजेंट. कीटो फॉर्म यू नो ना, दिस इज कीटो फॉर्म. It is having hydrogen. So now it is going to form a enol like this way. This is enol tautomerism. तो यहाँ पे भी मिथिल मिथिल ग्रुप है, लेकिन यहाँ पे तो हाइड्रोजन है ना, हाइड्रोजन और हाइड्रोजन. सो इसमें हाइड्रोजन है, इसमें हाइड्रोजन है, इसमें हाइड्रोजन है कीटोन के पास, लेकिन इसमें हाइड्रोजन नहीं है. सो व्हाट इज अवर करेक्ट आंसर? अवर करेक्ट आंसर इज व्हाट? ऑप्शन डी. कीटो इनॉल फॉर्म करने के लिए डज नॉट शो पूछा था, इसलिए जिसमें हाइड्रोजन नहीं है वो मैंने ऑप्शन यहाँ पे चूज कर लिया. दैट इज ऑप्शन नंबर डी. ओके, यस. The compound which does not contain enolizable hydrogen will not show ketoenol tautomerism. That is option D. Very good. So that's it for our today's session. Right, paper discussion. Thank you for attending this. Do you have any doubt in that? You can talk to me. If you have any doubt, you can talk to me. So most of the question we have covered here. Okay, I have covered most of the questions here. If you have any doubt regarding this discussion, you can talk to me right now. Any question? Okay, thank you so much for joining in. We will meet tomorrow, okay? Yeah, thank you. I will stop the share.